This is All Things Ansys, a podcast from the technical support staff at PADT. Episode 57. Doug Oatis discusses what is new in topological optimization and additive suite in Ansys 2020 R1, along with news and related goings-on from the world of Ansys. Welcome all from a cloudy day here in Phoenix, Arizona. It's been a busy week in what is usually the Valley of the Sun because it's Phoenix Startup Week. That includes Venture Madness and a host of other events, so lots of us have been running around town learning and networking and helping our customers that are in the startup world and all sorts of stuff going on. So it's been a little bit of a busy week, but it's the end, and it was a good week. As far as the podcast goes, the number of listeners has been going up. By a small amount, but I'll take it. Our average per episode went from 315 2 weeks ago to 317. So I'll take that any day. The numbers are 56 episodes. And that is 17,744 downloads. So it's a lot of downloads. Thank you very much for supporting the podcast and continue to spread the word with other folks who might be interested in listening. Last week, on an unrelated note, I was at the Pacific Design Show with a couple other people from PADT. We had a booth there. It's also called MD&M West and I think Packaging West or something like that. There's a whole bunch of different shows kind of on top of each other. And we were kind of in the back corner there, but lots of people stopped by and said hello. It was great to have so many people specifically stop by to say they listened to the podcast. And so that was always nice to have as we were standing there in our booth trying to attract people to do business with us. So thank you all for that. It does mean a lot, actually, when people give us a little shout out in person like that. Also, I have too many things on my plate, and I'm about 4 days behind schedule on multiple important projects. And then there's a whole bunch of stuff that I haven't even gotten to that's maybe a month old. So I'm going to jump right in to our talk with Doug and get started. As we continue to look at Ansys 2020 R1, we now come to one of the most popular topics on this podcast, topological optimization and modeling of additive manufacturing processes, specifically metal. Doug's been studying up on this, and he's got some cool things to share with us. So here he is. Welcome, everybody, to another discussion with Doug Oatis in our Littleton office in Colorado. Is it snowing again? And are you guys done with winter?
January was shockingly dry, and February has made up for that.
Okay.
So it's been relentless lately. But
so I'm arriving Sunday afternoon. Should I bring my ski coat? Or
that's more than 12 hours out, so it could be could be 70 degrees, it could be 12. So bring a bathing suit and a parka.
I'll bring my parka and my gloves and my summer wear. So
you're from Arizona, so if it's 60, you're cold.
Yeah, that's true. I die anyway, and I sit in the office and with my jacket on because you guys keep it cold. But that's not what we're here to talk about.
No.
What we're here to talk about is what is new at Ansys 2020 R1 in two very closely related things, topological optimization and additive manufacturing. You're going to be doing a webinar about that. Is it next week or the week after?
Oh man, I haven't looked at my calendar in a week and a half, so I hope it's late next week at the earliest. So,
and we'll link to that in the show notes, and definitely remind Doug. I have seen the presentation; it's ready to go, so we just need to get on his calendar.
Okay.
So we've had both new versions of topological optimization and, of course, new additive manufacturing tools for a few releases now. And before we started the podcast, we were kind of talking about what's in 2020 R1, and it seems like this is kind of a go back and improve productivity, fix some missing holes, that kind of a release. Is that a valid statement?
Yeah, I mean it's one of these where I don't like. There's a couple kind of big new things in beta, and just because there aren't any huge flashing new things, it doesn't mean that it's not a good thing.
Right.
Just because we've had some releases that have given us quite a lot of new features, and so going back and just making sure that everything plays nicely, or at least simplify the process, or even fix defects in prior revs. That's not a bad thing. It's overall reduces my headaches at least.
Right. It's from a support standpoint. Yeah. So let's start with topological optimization. which is a cool thing. And for those that, it's a very popular topic. We get a lot of downloads on our podcast when we talk about topological optimization, and also our webinars for that, including the one that's coming up, has been subscribed to quite well. But for those that don't know what it is, you're basically taking a model, applying loads to it, and then either moving the surfaces or removing elements in order to get an optimized shape based upon the loads that you've applied. So it kind of drives towards the shape based upon the loads. And topology, of course, means you can add holes and remove holes, or instead of having 3 struts, you got 2 struts. And shape optimization is where we just kind of move the surfaces around. So what's your favorite new thing at this release in the area of topological?
Well, I mean, in the past few revs, there's been quite a bit of work on adding the ability to essentially string together multiple environments that drive how you arrive at your optimized design. So not only are we looking at deflections, stresses, that kind of stuff, but the natural frequencies, thermal environments, and stuff like that. And so kind of the lead up to running a topology optimization can be multiple simulation environments that are being solved in order to drive that change. And so the next step in any topology optimization is making sure that what was spit out is actually appropriate or would actually work. And so the big thing that I've run into is the functionality of essentially rebuilding your validation system. And so that's been there in the past. But what the transfer to design validation system button or right mouse click on the project page does is all of those environments that feed that topology optimization run, they're rebuilt for you. And also behind the scenes, it runs a smoothing operation on the mesh that's output.
Okay.
So what isn't really discussed is you actually have to insert that smoothing operation into your topology optimization run. So all you do is right mouse click on the topology element density. I'm going from memory, so it might not be verbatim. And you just insert a smoothing operation. Okay. And you specify that you want to export the file. That's all you have to do. The benefit to doing that is that one, it runs a smoothing operation on it, so it kind of cleans up some spikiness. But when you go into your validation systems, all of your boundary conditions are there for you. You don't have to redo that. Nice. And so, before this, you'd essentially have to export the STL, go into space claim, either reverse engineer, or at a minimum run like a shrink wrap or a smoothing operation to kind of fix it's essentially dirty CAD that comes out of just faceted. But then you have to make sure that you preserved those areas so you could reapply your boundary conditions so you could actually see what the stresses and strains are, or temperatures. I for some reason I keep forgetting that thermal's been there for multiple years. And so you can run through and actually see how your optimized shape performs. Cool. And so that's pretty big. And then I'd hinted at fixing defects for if anyone was doing lattice optimization. So that's kind of standard topology optimization, whether it's density or level set based. You're essentially taking a box and then whittling away at some structure that meets your needs based off of some criteria and some objectives. Whereas lattice optimization, rather than changing the overall shape, we are filling the inside of it with, there's probably 6 to 10 different lattice infill types, whether it's just a basic cubic or I'll butcher the rest of them, but it's just different unit cells that'll fill your part. And then you can have a varying density. So basically, some lattices will be nice and thick where you need the stiffness, and then they'll thin out to where you don't need the stiffness. So kind of a way of playing around with the infill of your part. So that's a 2-step process. You run the lattice infill topology optimization run, and then you feed that into space claim, and then space claim actually generates the STL file of the essentially hollowed out infilled part. Right. And so that worked at 2019 R2. 2019 R3, oops, that didn't quite work. 2020 R1, it's working for me. So, good thing.
good sign.
Right.
I know I always hesitate to point out bugs, but yeah, Ansys every once in a while has a defect, and they do fix them, so that's good.
Yeah, it's right. I mean, I wouldn't have a job if people weren't making mistakes every day. So yeah. I have a hard time dealing with that sometimes, but it's
job security.
Right, exactly.
So that's cool. So a really big workflow fix there.
Mm-hmm.
So we kind of focus on the topological optimization itself, but the things you're talking about are kind of like, okay, I got the shape done. Now I want to double check it and do a more rigorous simulation on it. I don't have to recreate that workflow. It's the various parts that go, loads and things that go into that, and then also make it a lot easier to take that step into for the infill for the lattice structure. So those are two really important things. Let's talk a little bit about there were some improvements done to so there's two methods, right? There's the density based, where they're basically just reducing the stiffness and density of the elements and turning them off if they get thin and less dense enough. And then the other one being the level set. What improvements have been made on the level set side?
A great question. I mean, the only thing that I think there's been some enhancements just in kind of the different from previous revs. Some of the manufacturing constraints have been added there, so that's not necessarily new in this rev, but just if you were using level set when it was beta. So I mean, level set is for all intents, it's a toddler right now. Like it's a pretty young feature,
right? And
so each rev, the more use case that we see and use, and the more things that break it, the better it gets. And so as far as the level set's concerned, there's some improvements, or at least some modifications on how you can have multiple objectives. So essentially, if you have multiple environments that are driving the level set method, there's different ways of handling, whether it's like a normalized or just a standard summation of kind of how you treat the two different load cases that feed into that optimization run.
Okay, cool. So just kind of another more refinement and improvements, yeah.
Right, and I mean, level set, the big thing in past revs. So last rev, it's always kind of entertaining when a new tool set gets new features and the old method it kind of lags behind. And so last rev, there were additional constraints on center of mass, moment of inertia. And so that way, if you're looking to replace a part based off of some dynamic environment, you're trying to make sure that, as I'm not only changing the material, but I need to make sure that dynamically I'm not walking into a trap. Basically, exactly. I want to make sure that from a CG moment of inertia point of view, that I'm basically arriving at the same CG location, mass, value, moment of inertia. That was included in level set in 2019 R3. And so what's happened now is on the density based. So
it's gone back and added.
That's been added in. And so that's a beta, but it seems to be working for the cases that I've seen. But, it's with all things beta,
it's all beta.
Yeah. Right. Everything's beta, right?
It's all beta. Everything's beta. It's a valid point, I think, to bring up is when you're for a while in the last couple of years, and probably a couple more years to go, as we keep adding this capability in topological, as well as when we talk about additive suite. there's a lot of good beta features. I think, unlike other parts of the code, I really encourage people to use the beta features. They may not work, but in general they do. And as we're moving forward and adding these capabilities, you can get access to them a lot sooner with the beta, and get some advantage rather than waiting another 6 months to a year. So always good to have beta turned on. Anything else you want to add about topological before we move on to? There's some stuff with node-based shape optimization, right? That kind of falls under that.
Right. I mean, I guess I'm slowly realizing that I'm an old Ansys user, and so we don't tend to necessarily talk about the discovery products.
Right. Oh yeah.
And so, just because they're not just toys. But they definitely have
value there.
There's value there as long as you understand the use case.
Right.
And so just there's been quite a bit of work on the discovery live side of things as far as topology optimization goes, mainly with some manufacturing constraints and being able to use multiple environments. And then let's see if I'm remembering correctly, if I'm going to jump back to the mechanical suite real fast, and just the ability to use bolt pretensions. That's actually something that I hadn't even used before in the past.
Okay.
So the limitation before was I believe the bolt had to be in the loaded position, and so now at least on the density-based method, it supports the locked. So you have bolted flange that you're trying to simulate that's there.
That's actually kind of a big differentiator. I was talking with some customers about they were looking at kind of an upfront topology optimization tool that maybe has a more designer-oriented interface, but it's single part. You can't do contact. You can't do fancy loads. You can't do all these things. And bolt pretension is just another example of getting more realistic loads, because your loads drive the shape, right? I mean, that's how it figures out the shape. And if you put in a wrong load, you're going to get the wrong shape. So,
yeah, I mean, it's there's quite a bit of Ansys has a lot of different tools, and so it's always a very understanding that not only what talks to what, and what physics coupling you can do, but also the level of granularity you want to get into. And so the Discovery Live, it's so that you don't find yourself painted into a corner later on, and so you're not basically walking into a dead end. So that's what it's there for. And then as soon as you're comfortable with kind of the guidelines you've gotten from your live session, then you can start diving into the details using other tool sets.
Yeah, it's a great way to explore other options very, very quickly. I mean, because for those that haven't seen it, Discovery Live is a really, really fast solver. So by putting topological optimization in there, you can iterate on these shapes and different topologies really, really fast. So you can find out whether your idea is going to work or not very quickly, rather than waiting. I mean, Ansys isn't slow, but it still takes a little while to get an answer. Whereas with Discovery Live, it's a couple of minutes and you've got a new shape. So I think that's pretty cool. Okay, let's move on to additive manufacturing. And
we could real briefly talk about the node.
Oh, the node-based shape optimization.
So yeah, I mean it's
not really topological optimization, but
right.
Yeah.
But I mean, you could put it under the umbrella of I have no idea what this should look like.
Yes, go figure it out.
Computer, you tell me.
Yes, exactly.
And so yeah, I mean, topology optimization is where we're actually modifying the topology. We're punching holes in things. We're turning solid blocks into strut structures and stuff like that. And so you can kind of say that any topology optimization, the input geometry that you define.
Mm-hmm.
What is output has to exist within that bounding box.
Right.
And so, whereas shape optimization, you're not necessarily constrained by what your starting shape looks like. Mm-hmm. And so what happens here is, rather than changing, we're not punching holes or anything like that. We're just changing the overall shape of our structure. And so kind of the interesting part of that is, part of the reason that you run through and do a validation study on topology optimization is because you can't actually visualize what the stresses, strains, deformations are on the optimized part. And so in the shape optimization, we're actually distorting the mesh. And so, we're pulling some nodes and elements in one direction, others, other directions. And so the bounding box doesn't really apply. That, that's where we're starting from, and then we can morph into a different shape from that. Two, when it's all done, you can actually look at the stresses and strains on the part. And so it's kind of a quick, depending on how much it was distorted, maybe you don't necessarily give that your full consideration, but it at least gives you a guideline of where you are. And so, again, it's beta. And so, I don't want to say use it at your own risk, but
try it out. I mean,
it's an interesting use case.
Well, and so traditional optimization, shape optimization is, you go into your CAD package or your APDL file back in the day, your APDL file that built your geometry, and you assign parameters to be varied, and it moves the parameters and figures out the optimal shape. So this is really a lot more freedom in that it's the XYZ position of every node becomes a parameter that it can play with. It's going to be interesting to play with as it gets more mature. I think it's going to lead us to even better designs. So, again, we're moving away from those assumptions we make as design engineers up front on how to constrain a part or how the geometry can be varied. So, pretty cool. So additive.
Now I'll let you drive it.
Let's go into additive. So just as a reminder, the Ansys additive suite is really focused on what we call metal powder bed fusion or direct laser melting. There's a lot of different terms that people use, but it's basically taking a laser, drawing on a bed of powder, melting that powder where the laser passes, lowering the little elevator lift underneath the powder, and then putting a new layer of powder on top, and then melting and solidifying that layer. And the whole reason why we do simulation is you're taking metal, you're heating it up with a laser, you're melting it, and then you're cooling it. So the thermal stresses are insane, as is the resulting structure, microstructure behind it. So that's what the additive suite is all about. And let's start with the pre-processing. So we've got some tools built into SpaceClaim. What do they call it? I forget.
Additive prep.
Additive prep, which is the obvious name. That's why I never remember it.
Right. It's like a weird fishbowl of just additive blank and additive something, and then like there's a lot of different names, a lot of different products, and so it can be a little tricky, kind of wrapping your head around and kind of understanding what does what. But yes, additive prep is used on the prep side before you actually build something. It is in SpaceClaim. It is not a solver. And so it does have the ability to kind of show you, it's basically using a rules-based assumption. So again, no calculation, no solving for temperatures, stresses, deflections, anything like that. It's just straight up rules-based, and helping you figure out what's the right orientation I should print this at. Right. And that's based off of what support structures I'm going to need, how likely I am to distort, or distort less, and essentially how long it'll take to build in that orientation. You can apply different weighting factors to it, and so that was all it could do. 2 or 3 revs ago, and so 2019 R3, we started being able to generate actual build files, play around with different, and see like layer by layer slicing and stuff like that. We can actually insert a host of, all of your favorite support shapes, whether it's, heart cells or, just straight up bars or anything like that. So, what's interesting in the additive, especially the powder bed fusion, is that the supports not only, one, hold it to the plate, but it also provides a cooling mechanism. Right. So, you can play around with, some rules based. You can put in your own customized version of it. You can do a whole bunch of different things with how you actually support your structure. It's one of these where there's probably, well, I was going to say there's no wrong answer, but there's probably a lot of wrong answers.
There's a lot of wrong answers.
You're right. And so you could say there's an infinite number of ways that you could be wrong and right in supporting your part. But the nice thing about simulating it is you don't have to pay, anywhere from 15 to 100,000 plus to fail at printing your part. So that's the point of all of this, is that we're doing it without running a machine, without catching anything on fire or breaking any blades or anything like that. So yeah, I mean, the big thing in additive prep is writing more build files, so more machine types are supported. You can modify more machine parameters, modify scan orders. It's got some cost estimators built into it. So, it's really to like the name suggests, additive prep. It's used before you go and build anything, just to make sure that you're building it in an optimal orientation for either maximum throughput, making sure you're putting as many parts as you can on the build plate, or making sure that the way that you're printing it will hopefully prevent it from distorting, breaking, anything like that.
Right. So kind of upfront, doing what if statements using some rules, and then if you need to do the simulation, you can move into the actual additive mechanical product, right? And
right.
model the build process itself. What's changed there?
Yeah. So now we get into even more names, obviously.
Yes.
And so, as far as simulating the build process, you can go one of two ways. And so you have workbench additive. You might see an acronym of WA. And so that is using the mechanical product. It uses, by default, a transient thermal simulation that is coupled to a static structural environment. It is wizard driven or template driven, where you essentially go through, specify your machine parameters, and then it builds the entire model for you. Not build the entire model for you. That was wrong. It builds all of the loading objects and sets up all the solver. You still import the model and do all that fun stuff. And that's the tool that has the layered tetrahedral elements and the ability to calculate knockdown factors based off of a voxelized support. So basically we can import kind of a zero thickness STL, and we essentially just kind of cuboid around all of that. And so new at 2019 R3 is the ability to essentially tie together these voxelized supports to our layered TEP mesh. And so that's, the pictures of it make me just remember like the CEINTF command. Exactly. Essentially writing constraint equations. And so, and so it's one of these where, it's not necessarily, I don't view it as numerically new, but application based. It's a really nice way to play around with connecting how we represent supports in Workbench Additive and how we tie it together. Because otherwise, if you think about it, you basically have to line up node to node and tie everything together, or get it like shared nodes. Sorry, I haven't eaten lunch yet, so I've got about like 10 minutes of talking left before I just completely
you crash,
dissolve. And so just tying that together and being able to run it without having to be a meshing expert.
Right. Good.
And so that's one tool, and one of the new additions to that one is being able to, rather than run it as a coupled thermal structural simulation, where we essentially took a solver method from the other product, which I'll talk about next, and it's an inherent strain method. And so rather than me solving for temperature and then passing that over and solving for thermal stress and strain, I cut out the thermal side of it because I know it goes up to melting temperature. And then I just apply that as a body strain. So it's like, I'm not the strain is known because I know what the temperature is already. And so obviously, if you care about how the temperature moves through the part and stuff like that, it's kind of a gross simplification of it.
Right.
But for looking at that level, that kind of first pass of simulation, it's a good one. And so that was beta. I think it was beta in 2019 R2. I can't remember if it was in what beta release state it was at R3, but it's been released. And so and so those thermal that solver method's been included.
And you'd use that to just get a faster answer.
Correct,
right? Less accurate, but much faster. Yeah.
Right. So we're not accounting for conductivity through the part. It's just a straight up layer by layer basis of essentially. We basically say ta-da! All these elements are active and they're stressed. They've distorted this, and we keep on building up through it. So yeah, it's a faster pass through the build process.
Okay. Cool.
And so again, that's Workbench Additive in the mechanical product template.
Okay. And then we got another additive product that's
it's like everybody gets additive. You get it.
You get additive. Additive.
It's a really boring Oprah show. And so then the other tool set is additive print, additive science. Okay. And so those products, oh my gosh, I can't remember why I'm forgetting the name of the company.
3D Sim.
3D Sim. I thought that was it, but now I just look like a coward. I'm just a coward for not being not believing enough.
Believe in yourself. Don't play trivia.
But yeah. So additive print or 3D Sim, that purchase, Ansys has had two products from that. So that's additive print and additive science.
Right.
And so the benefit to these two is it allows you to really dig in deep to the actual build process. And so additive print has, I think it's 3 different simulation types. We have the inherent strain functionality where just layer by layer, go through and do all that. All the way up to actually using scan data and build files. And so you can start playing around with, what happens when I can take my build file for my specific machine and see what actually happens in my part. And so kind of where when do I use Workbench Additive? When do I use additive print?
Right.
If you have a machine in-house, you can calibrate your additive print to your specific machine settings.
Good.
And so there's some documented, build files that you go through and you print it on your machine. You take some measurements and then you back out what the scale factors are. You apply those in, and so now you kind of have a tailored solution for your specific machine in house. Whereas the Workbench, the mechanical Workbench Additive tool, we operate on a layer by layer basis rather than working with actual scan data. And so but kind of the big things on the additive print side of things is some additional materials. I can't remember the specific one.
Yeah, I saw a list that had a lot of numbers and letters.
Aluminum,
AL, blah blah blah.
Yeah, it's either an additive material or the hottest new club in town.
Exactly. Or maybe both.
Right. So that's been there. Some additional. There was a size constraint on the actual size of the part that you could simulate being printed, so that's been increased. There's a beta feature to read EOS build files, which is big. Just because before you had to go through and essentially just input some scans, some rough scan inputs, and the way that additive print built up the resultant scan vector was very similar to EOS. And I butchered that description. I apologize, but basically it was an equivalency rather than a direct one-to-one read.
Right.
So that's the take.
Now we can read it directly in, and we can play with those parameters and see how it impacts our build. Yeah.
And Trying to remember some of the other stuff, but
A lot of little productivity things.
I mean, I would say, the big thing was kind of the size limitation. More materials is always better, and the I'm trying to remember the details of it, but the ability to run the cutoff simulation.
Right. The progressive plate separation, right?
Right. So essentially the ability to solve for something within additive print and then go into Workbench additive, just because, what's really weird in the additive side is based on how it's printed, there are different ways that you can kind of approximate the effect that a heat treat has. So the basic way to simulate that is you essentially just zero out the thermal strains.
Mm-hmm. Assume a perfect heat treat. Yeah.
Right. I remember in my heat transfer class, you always have to write your assumptions at the very top of the homework problem. Mm-hmm. And so we'd always joke that the first assumption was assume adiabatic.
That's right.
So you're done. You don't have to do anything. So I mean, there's some very simple assumptions you can go through and do that, but really a lot of the heat treatment is more of a creep law behavior.
Right.
And so the ability to take information from additive print and then run it through a workbench or a static structural simulation, even though creep has a time component, we typically neglect mass integration effects for it. So you can take the output from that, run it through Workbench, get see what actually happens for any type of relaxation, and then being able to actually do a cutoff application, and not only just basically now you see it, now you don't type of removal from the base, but actually progressively cut off your part. And so I haven't yet quite dug into the details on that one, but anything that reflects reality is always a good thing in my book.
Yeah, that seems like when you kind of slowly cut off the area between the supports and the base plate. Right. It wants to potato chip off, and then if you do it slowly versus all at once, you're going to get a different response. So that's going to be cool to see. I've got some parts. We've got NASA Army STTR BIR that we're doing some 3D printing for, and hopefully in the phase 2 of that one, we'll be able to play with some of these simulations and improve that design. So I'm kind of looking forward to that particular, because it's going to be a major driver for these parts, because they're funny shaped, kind of concave, convex combined together. So
they're always funny shaped. Yeah. If it wasn't a funny shape, you'd just hog it out, right?
That's right. You would just machine it. Yeah.
I mean, that's part of the problem. It's you can print anything, so obviously it's going to be complicated.
Weird. Yeah, it's kind of a Pringle to begin with, and then what's it going to look like when we remove those supports? So it's going to be a good one to look at. Anything else you want to add that's new or people need to know about, or should try? I think we covered it all.
Yeah. I don't know if it's the recent travel or what, but I mean at least approaching from the topology optimization side of things. I'd say this is a bit more kind of just smoothing the edges a bit, and just making sure that everything's working kind of release with some pretty cool kind of beta features, and a redo, or at least some simplification in how you validate a bunch of stuff. And then a lot of the other things I wouldn't necessarily call them showstoppers. They're more just kind of consistency across products.
Good.
Or at least data transfer between products.
Well, I think we're kind of at that. I mean, you mentioned the toddler phase and the different phases in a product. This is a really difficult. Both of these are pretty complicated products, technically. And I think one of the things that's going on is we've got a lot of users actually using it now. So it's kind of moved beyond the early adopters going, this is cool, and people actually using it to do real work. So I think we're going to see a lot of refinement in the next couple of releases as that feedback, which is something I'm always pushing on the podcast, is give feedback to development, because they need to know these things so they can keep improving it. Yeah. Right,
because I mean, especially with the additive stuff, there's been some consortiums or collaborations between industry, academia, and Ansys in order to characterize the behavior. This isn't something that we're making up, but it's the more kind of use cases, the more basically I want to say the more times you break it, the better it gets. But that's essentially how software works, right?
Yeah, exactly.
And so yeah, I mean, it's at that phase where the more any feedback is good feedback, right?
Yeah, and it's. I mean, I think the developers do a good job of asking people and trying to understand. But when it gets in people's hands is when you start really learning what's needed. So, it's
I didn't really mention additive science.
Oh yeah, let's talk about additive science.
Additive science, yeah, I can't remember what additions were made for it, yes. But I just wanted to close the loop on that because I realized I said the additive print, additive science, didn't say anything about it. So additive science is really more intended from a, and this is one of those tools where it's just a slow. Its nature is a slow kind of progression or incremental releases. So it's intended for playing around with machine parameters and being able to estimate, what the actual microstructure looks like, predict density, really predict, all, so it's most of the simulations on additive science aren't necessarily your actual part. They're just going to be, a block. And let's see, if we change the scan speed, we change the laser wattage, we change all these other different things. What does that do to my actual, microstructure? And so that way, this you can play around, take the restrictor plate off of your machine and play around with different machine parameters, and basically figure out, well, if I do this, what does that do for my actual end product? Like, what can that do for, depending on what I'm trying to live through, there are certain grain structures that would be beneficial or detrimental to what you're doing. So yeah, sorry, I forgot to close the loop on that. I don't remember what's new in it, but I guess I'll do a better job and be ready for the webinar.
Well, I think when it becomes it's really, like you said, it's going to be a long haul to get that product fully developed and fleshed out. And if you're in academia, if you're a student studying additive manufacturing, metal-based additive manufacturing, or maybe you're a material scientist or in a methods group at your company, you should be looking at additive science now as it's progressing and giving feedback. And there's some valuable tools in there that you might be able to use. But if you're a designer or a manufacturing engineer, it's probably not going to add huge benefit unless you discover a problem with microstructure. That's probably not something you're going to play with.
Right. Yeah. The use case and the user base is completely different. And so yeah. And I mean, as far as why it takes so long, it's because there's a lot of material characterization. And so it's not just Young's modulus, coefficient of thermal expansion, thermal conductivity. Yeah. It's like it's weird. It's weird thermodynamic behaviors and melt pool dynamics and stuff like that need to be properly characterized and tracked during the simulation.
There's a lot of scanning electron microscope images used in the process of developing the tool and verifying the tool. So it reminds me of my material science class, which was way too long ago for me to remember the details. But I remember microstructure was important for metal. So that's cool. Lots of good stuff. I think a lot of listeners have been playing around with some other tools that maybe got to market a little bit faster. If so, come back, take a look at what's in Ansys. If you've been holding off taking a look at Ansys for either topo or topological optimization or additive, it's probably time to really dig in deep to it. These are useful tools, and we're finding it useful here. Additive prep is the one that kind of took off here at PADT, and that we gave our manufacturing department access to space claim, and they just started using it without us bugging them because it was so useful. So it's been a good proof that it actually is a useful tool and has been helpful in them quickly figuring out how to orient their parts and supports and things like that, and fixing some problems before we even have to do any simulation. So there's a lot in there. I think that's it. Anything else you want to add, Doug?
And just Yeah, I think you nailed it. Where if you were upset 6
Right.
months ago, kind of deal.
Come back.
There's a lot of things that changed, and so yeah, I mean, especially I want to say topology optimization is kind of the one that everyone's looking for, but just because you could argue that is process independent, so it doesn't matter if you're printing polymer
Mhm.
or metal,
Or even machining, right?
right? Yeah, yeah.
Parts of machining.
Yeah. So
Yeah.
so yeah, I mean there's new features, new functionality each rev. So
Yeah. Check it out.
yeah.
All right. Well, thank you very much, Doug. And we appreciate, as always, your input. And hopefully people will learn more. The big advantage of the webinar is goes through these things in detail and shows pictures. So it's a little bit easier to visualize. And I guess I will see you Monday. But
Yeah.
otherwise, we will talk soon again about, I can't remember what, but it's on the schedule. So we will have another topic to cover. And yet they keep adding functionality. So we keep on having more things to talk about. So it's a good thing. All right. Well, have a great weekend. And thanks for your time.
Yeah, no problem.
Talk to you soon. So please do sign up for the webinar. It's on Tuesday, February 26th at 11 a.m. Phoenix time. Go to www.padtinc.com/events to get the details and a link to register. Or as always, you can go to brighttalk.com. That's one word, brighttalk.com, and search for PADT or Ansys, and you will find all of our recordings as well as this upcoming one. As I mentioned earlier, I am 4 days behind on important things and about 6 months on things like getting real commercials for this podcast. So I will read again the same statement I've been making for a couple of episodes, which seems to be working. Please consider PADT as your Ansys supplier if you are in the Southwestern U.S. and for simulation consulting and customization. We are also just as good at additive manufacturing and product development. So give us a try. We love what we do, and our customers tell us that we are good at it. So please do consider PADT and all the different ways we can help. Let's talk about the Ansys stock. It seemed to be doing very well until today. It's down. Let's see. I checked at 1 p.m. Phoenix time, which would be 3 o'clock in New York City. It was at, this is February 21st, by the way, Friday. It was at $285 a share. So that is, down a little bit. But the S&P in general is down today. It looks like some corrections going on. But the good news is on the 19th, which was 2 days ago, Wednesday, it hit an all-time high of $299.06. So almost crossed over the $300 a share threshold. So close. Not that it really matters that it's 300, but to people like me, anyway, it's all kind of funny money anyway. It makes a difference. So hopefully we will see them cross 300 soon. Pretty impressive. In fact, that is up 11.15% for the year, a month and a half into that year. Nice gain. And the S&P, for comparison purposes, is only 4.28% up as of 1 o'clock today on the 21st, which is a Friday. So definitely outpacing the market again this year. As a reminder, on February 26th is when they release their numbers for Q4 in 2019. So, we'll see what happens when all the analysts and the people that buy hundreds of millions of dollars worth of stuff take a look at those results and decide what to do. It'll be very interesting to watch, which is about all that mortals like you and I can do. So, Ansys News, do check out the new website. I think we mentioned it a couple times in the podcast, but I went there again today, and it really looks nice. It's a much more modern look and feel, and is making me feel guilty about how outdated ours is. But that's another one of those projects I haven't even started that I was supposed to have done 6 months ago. The only news that I could find in the Ansys world was they added 2 board members. One is a man named Robert Calderoni, which kind of sounds familiar. He is the current chairman of the board for Citrix, which is probably why you've heard him in the news. And he was the former CEO of a cloud-based company called Ariba that was acquired by SAP. And then he's now working at SAP and was working at SAP, and now he's on the board at Citrix. He has a background from the finance. He's like a CFO type guy, and he did financial stuff at both Apple and IBM, as well as some other companies. So we'll see how that changes things. And then the other one is a guy named Ravi, I'm going to butcher this, Vijayaragian. And he is a senior partner at Bain & Company, and he's the head of their Asia Pacific technology practice. So that seems like a nice fit. Somebody that understands the growth in that very quickly growing area. That's been a good area of growth for Ansys. So it'll be nice to see. I didn't see that anybody left the board. So with these two added, there are now 9 people on the board of directors. If you're curious, just go to the Ansys website, go to About, and you can, or just Google Ansys board of directors, and you can see who's on there. Of course, the CEO, Ajay, is on the board as well. There's no new PADT news for me to share. I picked 3 articles, as usual, from the Ansys blog that I think are worth looking at. I encourage people to always just check out the blog in any way, but these are the 3 that will hopefully tempt you to do so. This is Engineering Week, or Engineers Week. I always forget until it's too late. But in celebration of that, Ansys picked 5 people that work for the company as role models to younger people who are thinking to be engineers, are considering being engineers, and kind of put them out there as great examples. It's a cool article to learn them. 2 of them are some of PADT's favorite people at Ansys, and I was very pleased to see them there. And I agree wholeheartedly that they are fantastic role models, even to old guys like me. The first was Margaret Smith, who is an electronics simulation genius, as well as an operations genius, and just a good person who can understand complex problems, explain them to other people, and get stuff done. And then a long-term friend of mine and PADT is Chris Wolf, and she came from the Fluent side of things. She's a CFD wizard and a project manager wizard, I guess. I have to come up with another word. She does a fantastic job and is responsible for many of the wonderful things that are in the world of Ansys CFD, and just a very good person and a wonderful human being. And great examples. I'm glad they picked those 2. And I need to meet the other. Well, one of the other ones is the CTO, who I'm getting to know better, and I would also agree is a fantastic person. I just haven't known him as long as Margaret and Chris. And the other 2 I need to meet and get to know. Check that out. For Valentine's Day, they did kind of a fun post. They did a CFD analysis on whether you can aerate wine. As you know, when you get oxygen in the wine, it brings out the flavor and the fragrance of it, red wine, by pouring it from the bottle. You can buy those little aerator things that kind of go glug, 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 and aerate the wine. They took a look. I won't tell you what the answer is. Can you aerate it just by pouring it straight from the bottle? See what simulation tells us. And the third one is a serious one. It's about how to improve designs by compressing simulation analysis. And it's a guest blogger, an analyst, took a look at Ansys Discovery Live, which is a fantastic tool that we're a big fan of. We just talked about it with Doug. And he talked about how to really speed up design on real components using Discovery Live. And so it's a nice, outside of our little Ansys, I'll admit, biased world, look at how valuable this tool is. Our design engineers here at PADT use it in the ways that he's described to just kind of answer quick questions and get us to a better design faster. Check that article out. We don't have anything posted as I'm reading this or talking right now, but I promised Joe I would publish the article that he wrote last week that I'm behind on. And so it'll be up by the time this goes out. It's called Mesh Time Metrics Display, and it's a useful addition to the mechanical interface that shows you how long it took to mesh a part. So if you're always wondering when you make a little change, did it take longer or more or less, it's a neat little indicator of that. And his blog article will share with you how to get to it, how to see it. Upcoming events, we've got the webinar we talked about, Additive Manufacturing and Topology Optimization Updates at Ansys 2020 R1, and that's going to be on February 26th at 11. And as usual, you can listen to it live or listen to the recording, and we have more to be announced. Trevor's working on that. We're changing some software behind the scenes, so we're doing that, and hopefully we'll announce those using that tool. Other events that PADT is holding on, we're done for February. We got one more week, kind of partial week coming up next week. Nothing going on. But in March, it's starting to get busy again. So the first event is I will be in New Mexico at the Innovate New Mexico Technology Showcase. This is the tech transfer event where the labs and the university and other organizations that do technology transfer kind of share what they've got. It's a great event, and some really cool technology is exposed during that. And so that is on the 3rd, and I will be there all day at that. So if you're going to that event, stop by and say hi to me. I will be the guy that looks like me in the audience. I should definitely stop by and say hi if you're at that. We also have our annual 2020 PADT SciTech Festival Open House. So if you don't know the SciTech Festival, it's an event in Arizona that started as a month-long event and is now like a 4-month-long event. But it's a festival of science and technology, and companies like PADT and universities like the U of A and ASU open up their doors and provide tours and do activities and have fun events to help kids understand the fun and excitement and joy of science and technology. And so we always open up our doors in February or March. This is going to be the beginning of March this year. And everyone's invited, especially families. So if you want to see 3D printing and simulation and what it's like living the life of a beige cubicle dweller, stop on by. It's on our website. Check it out. It's from 5 to 8 on the 5th of March. At the end of the month, we've got 2 events as well you should be aware of. One is our annual Arizona Technology Council MedTech Conference, and I will be speaking about 3D printing about how people are using 3D printing in the medical space here in Arizona, and that's on the 26th, and it's going to be at venue 8600 up in Scottsdale. Check out our website or the AZ Tech Council website for that. Hope to see people there. And then the big event of the month is the 36th Annual Space Symposium. I went for the first time last year. I had a wonderful time. I'm very excited about going back. We're going to have a booth with 3 other Arizona companies that is being sponsored by the Tech Council and the Commerce Authority. And we're going to talk about space in Arizona, as well as PADT and the other 3 companies. So if you're going to be at the Space Symposium, do stop by. We hope to see you there. And that's it. I want to thank everybody for listening to this kind of hastily recorded podcast. But this is one more thing I actually got done on time, and I can keep trying to catch up on things. Do not forget to subscribe to PADT's newsletter at www.padtinc.com/opt-in. Spread the word. We'd love to see our subscriptions keep going up and our number of listeners go up and downloads go up. So please do let people know about the podcast and invite them to participate. And as always, do not hesitate to reach out to podcast@padtinc.com. Thank you for joining us for the All Things Ansys podcast, episode 57. As a reminder, this podcast is not affiliated in any way with Ansys Inc., and the opinions expressed are those of the people on the show only and not of their current or former employers. For more information, visit www.padtinc.com/blog, and please share your thoughts and questions through an email to podcast@padtinc.com. See you next time.